Hello. Today we'll discuss lead code question number 337 House Robber 3. In this question we have been given a thief who wants to steal as much money as he possibly can from a society which is in the form of a binary tree, and the only entrance to the society is the node given to us. It's called root. Now this thief obviously wants to steal as much money as he possibly can, but there is a condition in the society. If he tries to steal from any consecutive houses, the thief will be caught. So the thief has to ensure that he doesn't do this, and at the same time steals as much money as he can. So we have to return this maximum amount out. Now how can we done it? So now how can we do it? Okay, one observation that can be made here is that if the thief is, if he is stealing money from a node, from a tree, from now onwards we will call every house as a node. Okay, because this is basically a binary tree. So if the thief steals from any node, it is sure that the thief cannot steal from any of the neighboring nodes. Now the neighboring nodes involve the parent and the two children, which are left node and the right node. As we see in example number 2, if the thief tries to steal from node 4, he cannot steal from 3, 1 and 3. Okay, great. So in this way the thief will steal from all the possible houses without getting caught. So we have to return this maximum value of the amount that the thief can get. Now how can we do this? Okay, so one approach that comes to my mind is, what I can do, I can maybe try to find this amount for all the possible nodes where I am either taking the node or I am not taking the node. For example, if I am computing for this subtree which is rooted at this value, this node having value 4, so we will compute the maximum possible value that we can get for the case when I am picking this node 4, and for the case where I am not picking this value 4. Okay, for both the cases we will fetch the values and I will return as a pair these both values. First will be where I am not where I am not picking the root node, and the second will be where I am picking the root node. Okay, now we can implement this using post order traversal. Now let's see what are the cases that can be made. Okay, here, so first let's try to think for the case where I am taking the node for a given subtree, for a subtree on which we are computing these values. Okay, let's say the tree is noted at root a. Okay, now for the case where the root a is mm, uh, 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 for the case where we are picking the values from root a, we cannot pick any values from the root nodes of the subtree. So we have to fetch those values from the value returned from those subtrees where we are not taking the root node. For all of them we will do this. Okay, now for the case where I am not taking the root node, what will happen is we can either take the value where I am where we are taking the values from the roots of the subtrees, or maybe some combination of them. For example, if in example number 2, for the node with the value 3 given here, if I am choosing to pick the value 3, I cannot pick this value 4 and 5. I cannot pick this value 4 and this value 5. So I will pick those values from the pairs which are returned from these function. Else, if I'm choosing not to take this 3, I can either choose the values where I am taking the node or I am not taking the node for each node. Okay, now let's run this. Okay, first let's make a function. Oh, it will return pair. And it will take argument as pointers to each nodes. if this root is empty, I will return 0 comma 0 because no value can be taken because the node itself is null. Now let's fetch now let's fetch both the values from the left subtree, which are values where I am taking the node, where I am taking the root node for the subtree versus where I am not taking. So it will be values left. This will be called node. Okay. Now let's compute the maximum value we can get if I am taking the current root value. Okay, so it will be named as take root, will be root of value plus value of root plus dot first okay, great. Now if I am not taking root, then we cannot take this root value, but we can take any of the values from the subtrees because the root node is not there, so we have this freedom. So let's put maximum value same for the right side. Okay, now we have in the end we will just return these values, I guess. And in the end we will return maximum. Let's run it and see what happens. Oh, I think this is done. Let's see. Oh, oh, yep, it should be okay now. Let's see where we are making an error. We're not taking the root. Oh, again, this should be node value. Okay, sounds okay. Let's submit it now, and it should be ideally okay. Yeah, it got accepted. So the time complexity here will be big O of n, because for each node we are coming at each node exactly once, and we are computing linear operation, we are computing constant time complexity operations under it. So the time complexity will be big O of n. So I hope you like this approach. If you have any questions or any comments / discussions, please drop them down in the comments, and I would love to see them. Thank you. Bye.